Hello and welcome to a brand new series of Century 21 Tech Talk. I'm your host, Jeff Tracy. In this briefing, I'll be providing details about the design and technical specifications of the Mole. The Mole is International Rescue's underground search and rescue vehicle. It is carried to the danger zone by Thunderbird 2, often in Pod 3 or Pod 5. At 64 feet long and 26 feet in height, the Mole is compact enough to reach areas that would be inaccessible to larger excavating machinery. Like the other international rescue craft and equipment, the Mole was designed by brains. Its primary purpose is to tunnel into subterranean areas and recover anyone trapped inside. The Mole is carried to the drilling site on an advanced mobile platform. The platform is equipped with rugged, all-terrain caterpillar tracks, allowing it to cover inhospitable ground with ease. The platform incorporates a thermal imaging camera system. A battery of demolition missiles can be used to clear any obstacles barring the Mole's path to the drilling site, and the destructive yield of each missile can be carefully calculated to avoid injury to anyone in the vicinity. The Mole itself comprises two main components, the drill and the cabin. The drill is an incredibly powerful piece of engineering. It is constructed from a top-secret formulation of kahelium extract, making it practically indestructible and capable of tunneling through all but the most hardened layers of rock. The outer shell of the vehicle is heat-resistant, incorporating the same alloy used in the construction of Thunderbird 3 and the Firefly. This has proven to be very useful, as the Mole has often had to stand up to intense heat during previous rescue operations. In addition to the drill, the side-mounted caterpillar tracks provide greater traction underground when traveling forwards or when reversing along a tunnel. The vehicle can be controlled by a single operator from the forward console. There is additional space at the rear for a second crew member and bench seating for disaster victims, along with essential medical supplies and equipment. The interior of the craft is air-conditioned and shielded against heat and radiation. The rear storage compartment has space for 2 hover bikes and a variety of handheld rescue gear. 2 shielded airlocks provide access to the control cabin and are located on the port and starboard sides of the forward operator's position. The rear section of the Mole houses a jet thrust motor. This powerful booster rocket is used to drive the Mole off the transporter platform and through the surface level at the danger zone. The operation of the Mole can be summed up pretty simply. Having landed at the danger zone, Thunderbird 2 unloads the equipment pod and releases the entrance flap. The Mole emerges from the pod and proceeds to the drilling position as advised by the rescue commander. Once in position, a hydraulic jack begins to raise the Mole to the correct angle, and the drill starts revving up to speed. When the appropriate angle has been reached, the hydraulics are locked off, and the main motors are engaged. The Mole slides off the transporter and tunnels into the ground, following the course programmed by the operator. Course corrections can be made if the Mole encounters any impenetrable veins of rock or debris in its path. When the vehicle emerges at the desired location, the crew disembark through one of the forward airlocks and help the disaster victims aboard. In especially delicate situations, the Mole may stop short before it emerges to allow the remainder of the tunneling to be completed by hand lasers. Once the people in distress have been attended to and secured on board, the hatches are sealed and the reverse motors are engaged. The caterpillar tracks on the port and starboard sides of the hull provide excellent traction to allow the Mole to make its way along the entry tunnel. Breaking the surface, the craft slides onto the guide rails on the transporter platform, and the hydraulic jack lowers the whole thing back into original position. The Mole then returns to Thunderbird 2, where the recovered personnel can be given additional medical treatment while they await the arrival of the emergency services. Believe it or not, one of Brain's more recent modifications to the Mole allows it to function underwater. which could come in pretty useful if we receive a distress call from someone trapped underground by a flood. Field tests are due to begin any day now, so stay tuned for further developments. While the Mole is capable of handling many rescue scenarios alone, it is often utilized in combination with some of our other heavy rescue equipment. Such combinations include being paired with the Firefly at the scene of the Thompson Tower disaster, and with the recovery vehicles during the Sidewinder operation. The Mole has also seen action alongside the restraining unit and the laser beam cutter. As one of the more frequently used rescue vehicles in our fleet, the boys have been known to jokingly refer to the Mole as Thunderbirds 6. I guess that shows how much they respect the rugged piece of machinery and its instrumental role in saving many lives to date. Well, that takes care of the Mole. I hope you found this briefing useful and informative. Be sure to join me next time for another Century 21 Tech Talk briefing. FAB. Hello and welcome to another Century 21 Tech Talk briefing with me, Jeff Tracy. In this briefing, I'll be providing details about the operation and technical specifications of the Firefly. The Firefly is International Rescue's advanced firefighting vehicle. It is transported to the danger zone on board Thunderbird 2, often in Pod 3 or Pod 6. The Firefly is 47 feet long and 15 feet in height, making it comparable in size to a Tiger-type fire appliance. When not in operation, it is stored in the auxiliary equipment garage next to Thunderbird 2's pod selection bay. The large blade at the front of the vehicle is ideal for moving debris and clearing a path for additional rescue craft. It is constructed from heat-resistant Kahelium Extract X and can withstand temperatures far in excess of any other man-made material. The blade incorporates a Kahelium-infused quartz panel to allow the operator a clear view of the path ahead when the blade is in position. When the blade is not required, it can be raised on hydraulic hinges in order to provide an unobstructed view of the rescue area. The blade is usually raised when traversing uneven ground, en route to and from the danger zone. The nose of the Firefly is equipped with a powerful cannon, which can extend through a hole in the center of the blade. The cannon fires nitroglycerine shells with pinpoint accuracy. These explosive shells are used to blow out intense fires that would be otherwise impossible to fight using conventional methods. By creating a carefully calculated blast in the vicinity of the fire, the Firefly's explosive shells rob the fire of the oxygen it requires to burn, and the fire is extinguished. The craft is equipped with advanced thermal sensors, which are capable of detecting the most critical and dangerous areas in large fires. This information can then be used to combat a blaze in the most effective way possible. Additionally, precise readings can be more accurately triangulated from additional heat detection equipment and similar sensors on other Thunderbird craft. Like the Mole, the main body of the Firefly is constructed from heat-resistant material and is built around a set of durable caterpillar tracks. This rugged propulsion system provides the maximum power and traction needed to force debris out of the vehicle's path. However, if an obstruction proves impossible to shift with brute force, the Firefly can bring its cannon to bear, clearing the path with a volley of explosive shells. The rear of the vehicle includes a heavy-duty towing port. This allows for an additional supply of suppressant to be towed behind the Firefly for larger operations. The operator's cabin is accessed by a hermetically sealed hatch on the port side of the vehicle. The cabin itself is shielded from heat and radiation, and the controls have been simplified for ease of operation by an individual wearing a fire suit. Although the Firefly's hull is designed to protect against extreme heat, standard operating procedure requires the crew to wear protective gear. A multi-directional turret is located on top of the craft, which can propel high-pressure jets of water or specially formulated chemical suppressant. The nozzles can swivel left and right and can pitch up to an angle of 45 degrees. The protective gantry is raised when the turret is in operation. The system also incorporates a vertical high-pressure delivery outlet, which blankets the area directly around the Firefly itself with water or chemical suppressant. A typical operation for the Firefly can be summarized as follows. First, a suitable deployment site is chosen. Thunderbird 2 lands at the danger zone, releases the pod, and lowers the ramp into position. The Firefly moves out and proceeds on course as indicated by the rescue commander. Direction is often provided by International Rescue's mobile control operator, though in extremely hazardous conditions, the instructions can be relayed from the safety of the Thunderbird craft themselves. If the Firefly needs to clear a path to the objective, the clearing blade is lowered into position and power is transferred to the traction system. As the Firefly nears the objective, the operator may choose to activate the rear turret in order to lay down a blanket of suppressant in the immediate area. This course of action provides a relatively safe exit route if the craft needs to reverse away from the rescue site. In larger, more intense fires, the nitroglycerine cannon is deployed to blow out the most threatening areas of the blaze. Once the imminent danger has been suppressed, the operator can leave the machine and recover the personnel in distress. The fire suits provide enough protection to perform this action with a margin for safety, and they may choose to take handheld suppression equipment with them if the situation calls for it. When all personnel are safely on board, the Firefly can be maneuvered away from the danger zone. It often returns along its entry track, but can clear a new path if the original has been compromised during the rescue operation. The Firefly is our most advanced piece of firefighting machinery, but we also have other equipment for tackling fire hazards. The Firecat is a specially modified version of the commercially available Knox 50 all-terrain transporter. Brains has equipped it with a nitroglycerin cannon, in addition to a high-pressure suppressant pump. We also have a pair of Tiger fire tenders. While outwardly similar to the commercial models used by fire departments all over the world, our models have improved heat-resistant chassis and greater capacity suppressant tanks. These vehicles often provide backup for the Firefly on operations involving the largest and most dangerous fires. We even have a specially designed diacetylene cage apparatus that is used to fight fires inside elevator shafts. A tank of suppressant feeds sprinklers on the exterior of the cage, while a pair of mechanical grabs extend from below and clamp onto the stricken elevator car. The Firefly is often paired with other auxiliary equipment in the course of rescue operations. One such instance was when it cleared a path for the mole during the Thompson Tower disaster. The Firefly remains one of our most vital pieces of life-saving equipment, and I hope you've enjoyed learning about it. Join me next time for another Century 21 Tech Talk briefing. FAB. Hello and welcome to another Century 21 Tech Talk briefing with me, Jeff Tracy. In this briefing, I'll be providing details about the operation and technical specifications of the Fireflash. The Fireflash is Air Terranian's new Mach 6 atomic-powered airliner, capable of carrying 600 passengers from London to Tokyo in under 90 minutes. The Fireflash is a revolution in commercial air travel. The aircraft is 525 feet long, 82 feet in height, and has a wingspan of 250 feet. The Fireflash was developed over a 5-year period, and the design team included some of the greatest minds in the aviation industry. Before being unveiled to the world in mid-2065, the aircraft was put through rigorous safety testing and airworthiness trials. The main control cabin is mounted inside the tailplane, affording the crew a view of the entire craft, The instrument panels are the very latest design and include brand new technology, such as the thorium beam transmitter. The control cabin is situated directly above the engineering section, which houses the atomic reactor and is accessed by elevator. The atomic power system is another of Fireflash's remarkable innovations. Just a few years ago, the idea of a commercial aircraft being powered by atomic energy would have been dismissed as fanciful. However, the reactor's shielding is serviced on a regular basis to ensure its safe operation. The first-class passenger lounges are mounted in the leading edges of the Fireflash's wings. Helium-strengthened glass is used to maintain structural stability and to protect from the extreme heat of supersonic flight. The main passenger cabin is located in the central fuselage and is more luxurious than even the first-class services provided by other airlines. The port and starboard landing gear is housed within the wingtips of the aircraft, which are folded into flight configuration after takeoff. The lower deck of Fireflash is dedicated to storage areas and vital avionic equipment. The aircraft also has space for a handful of automobiles, and these are loaded into the vehicle deck by a hydraulic elevator platform. The underside of the fuselage has a number of inspection hatches, which allow the main workings of the aircraft to be accessed. The ground crew checks everything, from the elevator power unit to the backup hydraulic systems. A typical departure for the Fireflash can be summarized as follows. First, the aircraft taxis out of its purpose-built hangar, having been serviced and fueled. It stops at the terminal to collect passengers and load cargo. Once the doors and hatches have been sealed, the Fireflash leaves the terminal apron and taxis to the end of its allocated runway. An automated signal beacon gives final clearance for takeoff before descending into the ground. The Fireflash pilot engages full power, and the aircraft begins to roll along the runway, quickly gathers speed, and then lifts off. Once in the air, the Fireflash climbs at a steep angle, passing through the sound barrier at 35,000 feet before engaging its reheat boosters at Mach 3. These incredible motors propel the craft to Mach 5.3 by the time it reaches 200,000 feet. As the aircraft begins to level off, it reaches top speed of Mach 6 and a final cruising altitude of 250,000 feet. Based at London Airport, the Fireflash serves routes to France, America, Japan, and Australia. The latest announcement from Air Turanian states that they hope to open new routes to India and South Africa within the next 6 months. Despite its popularity with commercial organizations and the public alike, the Fireflash has twice fallen victim to the evil intent of saboteurs. The first instance was during its maiden flight, bound from London to Tokyo. Tintin was traveling on board, the start of her journey to join the international rescue team. Shortly after leaving London Airport, the authorities were notified that a bomb had been planted in the landing gear of the aircraft, and that it would explode if the Fireflash attempted to land. It would prove to be our first ever assignment as international rescue. Scott and Virgil proceeded to London at maximum speed, bringing with them our high-speed elevator cars. These flat-roofed vehicles have been designed by brains for just such an emergency. Taking direction from Scott, the Fireflash pilot and Virgil were able to coordinate a landing attempt, inching the giant aircraft down to the elevator cars racing along below. Applying maximum braking force, Virgil began to slow the speeding aircraft down, but the strain on the tires was too much, and the master elevator car, with Virgil inside, slewed out of control and crashed. The nose of the Fireflash dropped to the runway and skidded the last few feet to a stop. Thankfully, no one was hurt, and the bomb did not explode. The second sabotage attempt on the Fireflash tragically resulted in the deaths of everyone on board when Fireflash 3 was lost in the ocean. A subsequent investigation by the International Air Ministry concluded that a fault in the elevator power unit was to blame. However, International Rescue were called on to thoroughly test Fireflash, and Scott teamed up with Captain Hansen to fly the aircraft on the same course. During the flight, the EPU system failed, and Gordon was winched aboard to find the cause. He discovered that the wires had been cut by a saboteur, who fired on Gordon before jumping out of the open hatch. Gordon was able to repair the EPU circuit just in time to prevent the Fireflash from crashing into the sea. Since then, there have been no further attempts to sabotage the Fireflash, thanks in part to increased security measures as a result of the previous incidents. I trust that you enjoyed learning about the Fireflash, and hope that hearing about our involvement with the aircraft hasn't put you off flying on one again. Statistically speaking, it's still the safest way to travel. Thanks for listening, and I'll see you again for another Tech Talk briefing. FAB. Hello and welcome to another Century 21 Tech Talk briefing with me, Jeff Tracy. In this briefing, I'll be providing details about the operation and technical specifications of the Sidewinder. The Sidewinder is the prototype for the Jungle Cat series of all-terrain transport walkers used by the U.S. Army. It was developed in response to the increasing number of so-called bushfire wars occurring on the African continent. The Sidewinder is one of the largest land vehicles ever designed by the U.S. military. With its forward grabs fully extended, the craft is 295 feet in length, and standing fully upright, it measures 100 feet in height. When carrying a full payload, the Sidewinder weighs 500 tons. Despite its huge bulk, the Sidewinder is able to move at a maximum speed of 50 miles per hour, thanks to its innovative gyroscopically controlled motion system. Each of the four legs incorporates a series of hydraulics for maximum mobility and stability. The footpads at the base of the legs are sturdy and provide ideal support for the machine. Two highly dexterous grabs are positioned at the front of the Sidewinder. These powerful multi-purpose tools are primarily used to clear obstacles, such as trees or rubble, out of the machine's path. They can be positioned to almost any angle and have an individual lifting capacity of 75 tons. Several weapons batteries are positioned on the top, sides, and base of this Sidewinder. The cannons can fire standard artillery or crowd control rounds such as X9 suppression gas. The remainder of the machine's hull is covered with armor plating, which provides protection from direct assault, heat, and radiation. The Sidewinder has an optimum operational crew of 30 enlisted recruits, but can be crewed with just 3 personnel during training exercises. Relief crew are transferred by helijet to the Sidewinder's location at the end of each exercise. The Sidewinder is operated from the control room located at the front of the machine. The control room is state-of-the-art and features ergonomically designed interfaces with remote links to all key systems and emergency backups. The Sidewinder may be called on to operate in extremes of temperature, in the hottest deserts or harshest Arctic wastes. To make life bearable for the crew in these vastly different operating environments, the Sidewinder is fitted with an adaptive heating and cooling plant, powered by the same fusion reactor that supplies the rest of the machine. This air conditioning system automatically keeps the temperature on board within set parameters, unless it is overridden. As an addition to the shock dampening system built into the machine's legs, the Sidewinder also features Gravimex floor plating. This proprietary technology acts in a similar manner to the artificial gravity plating on board Thunderbird 3 and Thunderbird 5. If the Sidewinder's positioning sensors detect the craft moving past a preset angle, such as when advancing up a steep incline, the Gravimex plating will engage automatically, keeping the crew upright, regardless of the machine's orientation. Now that we've discussed the Sidewinder itself, let me tell you how International Rescue came to be involved on a mission to rescue the machine. After the successful completion of an early training exercise under the command of Colonel Sweeney, the Sidewinder was en route to rendezvous with the relief crew, when the ground beneath it gave way and the machine tumbled into a burning underground pit. The crew weren't seriously injured by the initial fall, but the Sidewinder lay 300 feet below the surface and had landed on its side, with no way to right itself. Overseeing the operation, U.S. Army General Peters ordered an attempt to salvage the stricken machine by lowering a cable and attaching it to one of the Sidewinder's legs. Unfortunately, the attempt failed, and the Army personnel involved were badly burned. The hull was starting to crack, and the air purification system was failing. The situation was desperate. General Peters sent out a direct call requesting International Rescue's urgent assistance, and I dispatched Scott, Virgil, and Brains to the danger zone. Arriving in the desert, the boys assessed the situation, and Brains determined that the pit had once been an underground waste dump for surplus military equipment, which had spontaneously combusted over time. For the Sidewinder and its crew to be safely hauled from the pit, the remaining unstable topsoil at the edge of the crater needed to be removed. The Army readied their helijet, and Virgil, in his fire-resistant suit, was lowered down into the pit in order to lay demolition charges. The theory was that the charges would blast away the topsoil and provide access for the heavy rescue gear. Next, the mole was quickly unloaded from Thunderbird 2's pod, and with Scott at the controls, the drilling operation began. Boring down into the earth, Scott received navigation information from Brains, and on full power, the mole soon emerged into the bottom of the pit. Having placed all of the demolition charges, Virgil boarded the mole and took up the rear cabin position as Scott reversed course and brought the craft back to the surface. When the mole was safely out of range, Brains detonated the charges, and their explosive force blasted the remaining topsoil layer away from the edge of the crater. With the obstructions clear, Virgil piloted one of the International Rescue recovery vehicles out of the pod. A second remote-controlled vehicle followed behind, and they made their way to the side of the pit. Once in position, Virgil fired the magnetic clamps from both vehicles, and they attached to the hull of the Sidewinder. Utilizing incredible traction and raw power, the recovery vehicles began to haul the Sidewinder clear. Each moment brought the crew closer to safety, but it was a hard-fought battle. However, he was able to haul the Sidewinder free at last, and the crew were taken to hospital, where they made a full recovery. The disaster aside, the Sidewinder proved to be a formidable machine, and the Army have improved its design over time. From the lessons learned during the operation in which we were involved, they have even incorporated hoverjets in the underside of the Jungle Cat machines to further reduce the chance of a critical stability failure. And that brings us to the end of the file. I hope you enjoyed learning about the Sidewinder, and I'll see you soon for another Tech Talk briefing. FAB. Hello and welcome to another Century 21 Tech Talk briefing with me, Jeff Tracy. In this briefing, I'll be providing details about the operation and technical specifications of the Robotics International Crablogger. The Crablogger is a highly advanced mobile harvesting machine designed to collect raw materials and process them into wood pulp. The Crablogger is 342 feet long and weighs 435 tons. It can travel at a maximum speed of 40 miles per hour while in operation. The contract is planned and controlled from the accompanying base vehicle. The Crablogger base vehicle coordinates each phase of the operation, from creating the computerized tape that the Crablogger will use, to maintaining regular contact with the crew on board. A typical operation for the Crablogger works like this. First, the base vehicle's electronics engineer programs a route for the machine to follow and commits the information to a computer tape. The crew board the Crablogger by means of an elevator platform and seal the main hatch. The computerized route information is fed into the main databank, and the atomic motors are prepared for operation. As the atomic plant powers up, radiation shields are lowered in front of the control cabin. The chances of experiencing radiation exposure whilst operating the machine are minimal, but the enhanced shielding makes it even less likely. Switching on the ocular monitors, the crew are provided with a clear view of the path ahead, thanks to a set of cameras mounted in the Crablogger's superstructure. As the huge machine approaches its first objective, the initial clearance program switches into effect. Extending one of its powerful claws, the Crablogger clamps onto the target tree and holds it in place, while the large cutting blade at the front of the craft slices through the base of the trunk. The tree is then lifted out of the machine's path and fed into the opening of the processing plant. As the tree passes into the machine, it is stripped of its leaves and branches, then moves deeper into the Crablogger, where it is cut into preset lengths. While this occurs, the next tree is already being collected. Once cut into the appropriate size, the lengths of wood pass through a pipeline connecting the two sections of the vehicle. The rear section houses the pulping unit and barrel dispenser. The wood passes into the pulping apparatus and is extruded into a barrel at the other end. A typical logging program produces 60 barrels of processed wood pulp every 30 minutes. Every 15 minutes, a transporter will collect 30 barrels of pulp from the Crablogger via an automated collection point at the rear of the vehicle. This is achieved while the Crablogger remains in motion, so as not to slow down the clearance operation. The rear section also houses the Crablogger's fuel tanks, with a capacity for 1,000 gallons of Superon fuel. The tanks are resupplied every 3 hours by a dedicated fleet of tankers. When the Crablogger has completed its operation, it automatically shuts down at the predetermined position of the programmed route. Now, I know that the idea of tree clearance on such a vast scale might make some of you uneasy, but Robotics International have made it clear that no Crablogger will begin an operation before a number of trees equal to those planned for clearance have been planted elsewhere. Jim Lucas, the designer of the Crablogger, has always stated his intent to maintain the ecological balance of the world. However, despite the best intentions of Lucas and his company, the Crablogger's first operation was almost its last. Here's what happened. The Crablogger had been shipped out to South America to prove itself in the jungle down there, and for a while, everything seemed to be going according to plan. Not long into the first phase of the operation, one of the operators, a man named Peterson, collapsed at the controls. His fellow operator, McCall, raised the alarm with Crablogger base control, reporting that he too was beginning to feel unwell. Project Director Jansen ordered him to shut the Crablogger down. Unfortunately, McCall thought that he could manage to keep the machine running and finish the job, but passed out soon after. With no one to operate it, the Crablogger veered off its programmed route and began tearing through the jungle out of control. Jansen set out a distress call to international rescue, and Scott, Virgil, and Brains were soon on their way to the danger zone. Meanwhile, the Crablogger's new course had heading for San Martino. Fortunately, Jansen had radioed ahead, and the small village was evacuated before the huge machine crashed through it, leaving a path of destruction in its wake. The boys arrived quickly and unloaded the high-speed mobile crane from Thunderbird 2. Quickly catching up with the Crablogger, Virgil and Brains transferred to the machine and began to cut their way inside to get the crew out. While the rescue operation continued in South America, Lady Penelope and Parker were hard at work in England, tracking down Jim Lucas, the Crablogger's designer, in order to find out how to shut down the Crablogger before it collided with the new San Martino Dam. With the crew of the Crablogger safely on the way back to base camp with Scott, Virgil and Brains input the shutdown sequence transmitted by Penny. The shutdown sequence had a 3-minute time lag, and the Crablogger was perilously close to the dam. At the last moment, it began to move up an incline, leading it along a narrow ledge high above the dam site. The power plant finally closed down, and the Crablogger stopped. But the ledge was crumbling under the machine's weight, and it was still almost fully laden with fuel. If the Crablogger fell from the ledge, the resulting explosion would shatter the dam and flood the area for miles around, at the cost of countless lives. Scott arrived in a Superon tanker, and with the aid of Virgil and Brains, the tanks were slowly drained. With each passing second, the Crablogger lurched more and more as the ground gave way. The instant the final drop of fuel was removed, Scott disengaged the pumps, and Virgil and Brains shot clear on their escape packs as the Crablogger tumbled down into the construction yard in a tangle of twisted parts and metal. Although the disaster was far from the triumphant beginning Jim Lucas had hoped for, it highlighted the need for improved safety features in the Crablogger's design. The Mark II Crablogger incorporates a remote override feature, so the machine can be shut down from the base camp vehicle. These modified Crabloggers have proven their worth, clearing the way for road construction Pathfinders in the new highway developments around the world. I hope you enjoyed learning about the Crablogger. It's a fantastic piece of engineering, despite having a shaky start. I'll see you again for another Century 21 Tech Talk briefing very soon. Goodbye for now. Hello and welcome to another Century 21 Tech Talk briefing with me, Jeff Tracy. In this briefing, I'll be providing details about the operation and technical specifications of the road construction Pathfinder. The Pathfinder is a revolutionary self-contained mobile construction site. Its purpose is to build new roads and highways in remote regions of the globe. The Pathfinder is 280 feet long and 190 feet high, with a maximum speed of 30 miles per hour when traveling between road-laying sites. The machine has a crew complement of 12 personnel, including the operations manager, auxiliary craft operator, driver, spotter, and maintenance crew. The Pathfinder's control room is located on the top deck, below the main communications antenna. While the machine is in motion, the control room is manned by a minimum of 2 personnel, 1 operating the main drive system, and 1 on spotting duty to call out obstructions in the machine's path. When an obstruction is deemed too large for the Pathfinder to clear safely, the operator can bring the demolition cannon to bear. The spotter passes target and range information, and the machine's operator fires the cannon, blasting the obstruction clear. The machine is powered by a compact fusion reactor, which supplies all the energy necessary for its operations. The Pathfinder moves at 5 miles per hour while it is laying the new road surface. The tarmac is pre-marked with the desired pattern and cooled as it is extruded from the spreader behind the machine. Raw materials are provided by support trucks, which resupply the main craft at regular intervals. The upper hangar bay provides storage for a jumping jack helijet. This versatile aircraft is used to scout the proposed construction route, to check for hazards, and to assess the condition of the terrain along the Pathfinder's course. The helijet can be deployed from the Pathfinder while the machine is stationary or in motion. The front of the Pathfinder opens to reveal an auxiliary vehicle garage and turntable, which houses operation-specific equipment. The vehicle stored in the Pathfinder's garage varies depending on the environment in which the machine is operating. In heavily forested regions, the Pathfinder will often be preceded by a Crablogger, which clears the route for the Pathfinder to advance. In these instances, the Pathfinder carries a Crablogger support vehicle such as a Superon tanker or wood pulp transporter. In areas with desert or rocky terrain, the Pathfinder can deploy a powerful bulldozer to clear obstacles quickly and effectively. In mountainous regions or areas with larger immovable obstructions, the Pathfinder will usually be equipped with an explosives tractor. Though much smaller than the Pathfinder, the explosives tractor is a force to be reckoned with. Utilizing a battery of 16 projectile launchers, the explosives tractor can fire a series of precision-guided atomic charges. These high explosives make short work of anything in the vehicle's path, and are even powerful enough to cut a clearing through a mountain pass. Atomic charges are incredibly dangerous, and should only ever be handled by qualified experts. As a matter of fact, International Rescue were involved in a life-or-death operation at a Pathfinder site not long ago. This is the story. A guy called Eddie Hausman had been clearing the route for his business partner's Pathfinder in a treacherous mountain region of Southeast Asia. The construction company was really up against it to finish the project before the monsoon season began. Unfortunately, the monsoons arrived sooner than expected, and earth tremors threatened to destroy their work to date. Eddie was a stubborn guy, and against his partner's orders, he snuck out in the middle of the night and took the explosives tractor along a narrow ledge in the cutting he had cleared. Placing some atomic charges by hand, Eddie planned to detonate them at a safe distance and blow the mountain peak away to prevent it falling into the new clearing. All was going well, until the blast from the explosion carried Eddie's vehicle to the edge of the rocky ledge, leaving it balanced precariously with a case of charges still on board. With no way to reach Eddie safely, Bob Gray and his team contacted International Rescue for assistance. However, it presented us with a problem. You see, Eddie was an old friend of Tintin's and knew all of us at the base. If we went out to help him, our identities could be revealed and our operational security compromised. However, we couldn't just sit by and do nothing. So Scott blasted off in Thunderbird 1, with Virgil and Alan following in Thunderbird 2. Immediately on his arrival at the danger zone, Scott fired a barrage of steel spears into the side of the mountain, above the tractor, to prevent it from being struck by falling boulders. This delaying tactic bought enough time for Thunderbird 2 to arrive and assess the situation. The walls of the newly cut clearing were narrow, and Virgil had to navigate the freighter craft between them with great care. As Virgil lowered Thunderbird 2 towards the stricken vehicle, the downward force of its powerful retro motors almost caused the explosives tractor to overbalance and topple from the ledge. Retreating skyward once more, Thunderbird 2 began hovering, while Scott formulated a way to stabilize the precariously balanced vehicle. Using Thunderbird 1 itself as a means to steady Eddie's tractor, Scott inched the rocket forward until its nose cone was underneath the vehicle. With its engines on minimum power, Thunderbird 1 gently raised up, nudging the front of the tractor into position. Virgil once again brought Thunderbird 2 down over the vehicle, and this time Alan was able to make contact with the electromagnetic grabs. As Scott moved Thunderbird 1 clear, Virgil hauled the tractor free and into the air. However, the vehicle proved to be too heavy for the grabs, and one by one, they began to lose their grip. Guiding Thunderbird 2 as near to the edge of the cutting as he dared, Virgil closed the distance, enough for Eddie to jump clear. Seconds later, the grabs failed, and the tractor plunged to the canyon floor and exploded. Eddie was saved, and no worse for the wear. Equally importantly, he never saw the faces of his rescuers, and the secrets of international rescue were preserved. That brings us to the end of this briefing. Be sure to look out for road builders and the other equipment I've been discussing the next time you see a large construction project. I'll see you next time for some more Century 21 Tech Talk. Take care.